telling me. So, okay. The axial skeleton is the portion of the body. It's our bones that run in a straight line on a vertical axis. So if we're looking at our skeleton here in class, we would see that the axial skeleton is everything that runs from the top of the vertebral column to the bottom, as well as the ribs and the sternum in the front. So there isn't a lot to it, but it does a very important job for us because the axial skeleton, it gives us protection for the very important organs in the thoracic cavity. It gives us protection for the spinal cord, and it also allows us to move and use our muscles, not quite as much or it's as extensively as with the arms and legs, but it does still give us a certain amount of flexibility with our vertebrae, our ability to move. You know, our lungs have to expand and our rib cage has to expand and stuff like that. So let's, I've got a comment here. I can't hear anything. Can you hear me now? So, okay, it fixed itself. Okay. If all technology was that simple. So, okay, let's go ahead and get started here. Let me bring up the section on the axial skeleton. Okay, here we go. This is, obviously a picture of our skeleton here. And what we're looking at is the axial skeleton. It does not include the skull. We talked about the skull last week. The skull is totally different. It's not part of the axial skeleton or the appendicular skeleton. It is by itself. We went through all that. So now, first thing we see on the axial skeleton right here in the front is the sternum. We can feel our sternum. It's right here in the middle of our chest, the area we call the mediastinum. A number you have models, pieces there with you that have like you have one. This is the sternum right here. The sternum has three parts to it, and we can very easily find the end of our sternum by identifying this little tip at the bottom of the sternum. That's known as the xiphoid process right there. So I'm going to pass that around. But everybody should find their xiphoid process. Everybody should know where their xiphoid process is. If you've ever had a CPR class, the xiphoid process is a landmark. You don't put your hand in the xiphoid process. Bad things happen. So, but it tells you where the ribs or the sternum starts. So there's the sternum. There are the vertebrae. What we have, the top vertebrae, the top dozen or so up here on our skeleton are the cervical vertebrae. Below them, we have the thoracic vertebrae. The thoracic vertebrae can be identified because the ribs attach only to the thoracic vertebrae in the back. There are 12 pairs of ribs and there are 12 thoracic vertebrae. There are the ribs with 12 pairs of ribs. Here we have what's known as the intervertebral disc. If we look at the model I have up here, this one instead. The intervertebral disc is the, here we go. The intervertebral disc is this pad of cartilage between the vertebrae. We see it in our skeleton. We see it at the pubic symphysis, at the pubic bones. We'll look at that next week in here. But the intervertebral disc is the pad of cartilage that separates and cushions our vertebrae from each other. It is made out of what we call fibrocartilage. It's not as flexible as the hyaline cartilage in our nose or our ears, but what it functions as is a shock absorber. Because when we walk or run or climb stairs or do anything, shock of motion comes up our legs. We're not aware of it because it shouldn't hurt. Comes up our legs, comes across to the pelvis in the front and hits that pad of cartilage in the pelvis. And then in the back, it hits our sacroiliac joint and goes up our vertebrae. And the pads, the intervertebral disc pads of cartilage absorb that shock. So it shouldn't hurt to move. Okay. Now, and there is, now what you see there, they're very large vertebrae. Those are the lumbar vertebrae. The vertebrae that you see here on the model, right up there, this is a lumbar vertebrae. These are the largest vertebrae in our body. There are about 5 of those. We go from the cervical vertebrae to the thoracic vertebrae to the 5 to 7 lumbar vertebrae, somewhere in there in that neighborhood. They're the largest vertebrae in the spinal column, and then they terminate in a structure known as the sacrum, which is sort of a triangular shaped bone that a number of you, there should be a couple laying out there. You've got a sacrum right there on the, that's it, yes, that's a sacrum. It actually consists of 5 vertebrae fused together. That's the tail end of our spinal cord. Okay. So there's our lumbar vertebrae. Now, let's take a look at the ribs. There are 12 pairs of ribs. The first 7 pairs are called the true ribs. They are attached directly to the sternum. This is what essentially our ribs look like. And we'll see that the first 7 pairs attach directly to the sternum with by way of hyaline cartilage. You notice how the as this goes around, the ribs are highlighted in red, and then the cartilage is in white, and you can see how the first 7 pairs are attached to the cartilage, which then attaches to the ribs. The reason we have the cartilage is because the muscles that are between our ribs, when they contract, our ribs elevate. When our ribs elevate, our thoracic cavity expands. The lungs are glued to the inside wall of the thoracic cavity. So when we raise our ribs, our lungs expand and air rushes in. So we have to have this flexibility with our ribs so that the hyaline cartilage allows the ribs, when the muscles contract, the muscles would be between these bones of the ribs. The muscles are between there. We've all eaten ribs, right? Okay, we like ribs. Most people do. Yes or no, it's okay. But the ribs that we eat are the same type of ribs that we have in our bodies. The meat that we eat on a rib is the muscle that we use to elevate our rib cage. The contraction of these muscles, when they contract, the ribs rise. And when the ribs rise, they take the wall of the chest cavity with it. And when they take the chest cavity wall, the lungs are glued to the inside of the wall of the chest cavity. So when the ribs contract, they rise up and the lungs expand. And that sucks in air from the outside. So it's very important, a relationship there. We'll spend a lot of time in AP2 talking about it. So the first 7 pairs attach directly. 8, 9, and 10 attach indirectly. 8, 9, and 10, if you look at this model, you can see that 8, 9, and 10 are down here. And what, here is 1, 2, 3, 4, 5, 6, 7. This is the 7th rib down here. 8, 9, and 10 are below that. And you can see this. Let me see if I can show it on here. Bring this out of this. And now let's take a look here. So I can get this to, it worked. Okay. So what we're seeing here, this is the 7th rib right here. This is the 7th rib. 8, 9, and 10 are the ones down here. They attach indirectly. They attach to hyaline cartilage, which attaches with the hyaline cartilage, then attaches to the hyaline cartilage of the 7th rib. So we call them the, let's bring it back up here. We call those 8, 9, and 10 the false ribs, because they don't attach directly into the front. They attach indirectly. They attach to the hyaline cartilage of number 7. So they're sort of piggybacking on number 7. The 11th and 12th ribs don't attach in the front at all. We call those the floating ribs. And the floaters are down here at the bottom. You can see as this rotates around, you can see not 11 and 12, as they go around, they do not connect in the front. So only the first 7 connect directly, 8, 9, and 10 connect indirectly. But it provides us enough protection because underneath the ribs are the lungs, the heart, the great blood vessels, the aorta and the vena cavas. And of course, we have the esophagus and the trachea. And then further back, we have the spinal column and the spinal cord inside that. So the ribs are protecting all of that. So we, again, 12 pairs of ribs, 12 vertebrae. Now the ribs connect to the vertebrae in the back. So we have all the thoracic vertebrae, all 12 of those are going to attach to a pair of ribs. Okay, close up on this now. There's our sternum. Our sternum has 3 parts to it. We have the top part, which is known as the manubrium, the middle portion. It's a very technical term for the middle portion. It's called the body. It's easy to remember. And then my favorite portion is the xiphoid process right there. At least we can feel the xiphoid process very easily by just pressing here below your manubrium. You can find it right in the middle of your chest. The xiphoid process is where the diaphragm starts. And it also that marks the separation between the thoracic cavity and the abdominal cavity. And so it's right here in the middle. That's the xiphoid process, the pointy end, if you will. So the manubrium is at the top, the body is in the middle, and the xiphoid process is at the bottom. A couple other things here of note. There's a depression on the top of the manubrium. You don't see it much on these models, but there really is a notch there on the manubrium. The top, it's called the jugular notch. And remember the jugular foramens in the skull from last week? The jugular, the large jugular veins continue on their path downward, and they have to go behind the sternum to get to the vena cava. The superior vena cava is draining the whole upper third of our body from about here up. And so the jugulars come down and drain into the vena cava and then directly into the heart. And so they duck down as they come down from our skull, they duck behind the sternum at the jugular notch. There's also 2 notches on there for the clavicles. It's called the clavicular notch. And at the clavicular notch, they're on the side. Now, that's where our clavicle, our collarbone, you can feel your collarbone. Put your hands up there and feel your collarbone. Your collarbone continues on up to the top of the manubrium. You can feel the end of your collarbone. If you put your fingers right here and rub it, you're not going to hurt yourself if you rub there. You're essentially finding this portion of our clavicle. This is our collarbone, our clavicle. This structure right here is the end of the clavicle, and it is articulating at the clavicular notch. Why is that important to us? That's so I can ask you a question on the test, right? That's the only reason. That was sarcasm. Because somebody's like, yeah, because you can take it, ask a question now. Remember, our rib cage can move. It has to expand and contract. So the clavicle, our collarbone, attaches to our shoulder, and that gives a flexibility. Even at the very top, we can, because our ribs rise, and so our clavicle has to have a little bit of give there, and our sternum has to have a little bit of give, so our chest can expand. So our ribs expand when the muscles contract, and so we have this. It's almost like a little hinge in there, and when we take a deep breath, you can feel that moving up and down, right in there. So that notch is where the clavicles, it says clavicular, meaning clavicle, they come together. You can feel the ends of your collarbones right there, where they're articulating, where they're rubbing up against the manubrium. Okay, now there's your cervical vertebrae on the back side. The cervical vertebrae has a very important job. It has to protect our spinal cord as it's going into and out of the brain. It goes into the brain or out of the brain through the foramen magnum, that very large opening in the occipital bone. And as it's going down or going up, depending on what it's doing, we have nerves that are leaving the spinal cord and going out to the body. And we have nerves coming in from the body, going into the spinal cord and proceeding up towards the brain to tell us what's going on. Is your bladder full? Are you hungry? Does your back hurt? Are you thirsty? All this information that's coming in from all parts of your body, or these instructions to go out down the spinal cord. Raise your right arm, put your right arm back down. All these instructions are going up and down, and those vertebrae protect the spinal cord for us. There's the thoracic vertebrae there. And of course, they're going to continue the process of the spinal cord gets larger as it goes further down. Once we get through the thoracic vertebrae, we hit the lumbar vertebrae there. And then we have a structure below the lumbar vertebrae called the sacrum. And the sacrum is this structure right here at the bottom. This is called the sacrum. Put up a screen. This is the sacrum right here. The sacrum consists of 5 fused vertebrae, and they're still part of the spinal column, whereas all the rest of the vertebrae are individual bones. This consists of 5 bones that are fused together. And then at the end of the sacrum, you have a structure known as the coccyx, which is this little structure right here that consists of 3 separate bones fused together. Those 3 bones are simply points of attachment for muscles, as are all the wings and processes that stick out from the sides, points of attachment for muscles. See, because our vertebrae depend on muscles to hold them in place, and also for muscles to pull against them. And so we have lots of attachment for these muscles. Our backbone has a certain amount of flexibility. It's not this rigid, solid structure made out of concrete that can't move. Our backbone has a certain amount of give to it. Now, the coccyx, it's, all it does is really hold muscles in place, particularly some of the pelvic muscles. The coccyx will often be broken during childbirth. We call it the tailbone, and many people have broken their tailbone when they're delivering their baby because they're told to bear down, to press hard during delivery, and so they do, and they press so hard that their muscles will snap their bones, and the mother will have a broken tailbone, and then it heals up, and she's fine. Because there's not a whole lot you can do to treat a fracture of the tailbone. It's not like it's going to go anywhere. It's surrounded by muscle. It happens. I won't say it happens a lot, but it does happen frequently, and it is one of those things that will heal up very quickly. Bone heals real quick, and this is almost held in place like a splint, if you will, because of all the muscles around the tailbone. Bless you. Okay. Let me get back. Sharing. Okay, so there's the sacrum, and down here is the coccyx right there. And again, the coccyx, the tailbone, it doesn't do a whole lot for us, but it is a point of attachment for some of our pelvic muscles. There's the sacrum. You'll notice that there are openings in the sacrum. Those are for the passageway of nerves. Even though the vertebrae are fused together, you still see the openings for nerves to go into and out of the sacrum to go up towards the spinal cord. The spinal cord stops somewhere around the second lumbar vertebrae, but we have nerves that extend all the way down. And so we use these openings here to still reach out to other parts of the body here through that. You'll notice that there are no openings in the coccyx. And there's the coccyx there. This one shows you even more openings. This is a little better picture of this. You can see that this shows you that the sacrum really was fused from 5 vertebrae, because you can see, you can almost see the structures left over here where they came together. But there are at least 4 or 5 what we call intervertebral foramens. The intervertebral foramen is a foramen, a hole between the vertebrae, intervertebral. So this is our coccyx at the bottom of the sacrum. So how many vertebrae do we have? Well, we have 8. I think we have 32 altogether. 8 cervical, 12 thoracic, 5 to 7 lumbar, and then somewhere between 5 and 8, 5 and 3, 8 more down to sacrum and the coccyx. I'll give you a real number here in a second. There's the sacrum. So thoracic, rib, oh, okay, carry it with myself. Okay, thoracic vertebrae. These are unique in that they have points of attachment for the ribs. The other vertebrae, the cervical vertebrae don't, the lumbar vertebrae don't. Only the ribs attach to the thoracic vertebrae. In the back, they articulate. There's a point to articulate. And in the front, they're going to attach either directly or indirectly to the sternum, except for ribs 11 and 12. They don't attach at all. So there are the thoracic vertebrae. And this is a good illustration. It shows you the size of the rib cage, and we have all the very important viscera, the heart and lungs, found inside here. There is a certain bit of protection for the kidneys. The kidneys set up high here, just below the diaphragm, but you can see that the floating ribs 11 and 12 do project down, so there's a little bit of protection for your kidneys there, because the kidneys do set up very high. The kidneys are not low. The kidneys are not down here. Kidneys are up here right underneath the diaphragm. So there is a bit of protection from those two floating ribs. Not much. Bless you.
Thank you.
Now, this is not a fish. It looks like a fish, but it's not a fish. This is the vertebrae. They've been strung together. In fact, the vertebrae necklace is right there behind you, beside you. I'm going to grab that and I'll show you. This is that same structure that you're seeing on the screen. Thank you. And if you're really bored, you can spend all day trying to get organized. They probably got some student worker to do this for us years ago. But everything, what it's showing on the screen is that this stuff all nests together. We go from the very cervical vertebrae number 1 to the last of the lumbar at the end. That's all the sacrum. So this includes the sacrum and the coccyx in here. But what this does show you, though, the important thing this shows is that there are a series of openings on the sides of the vertebrae. These are called the intervertebral foramens. And this is the passageway for the spinal nerves to go into and out of the spinal cord. Because the spinal cord is contained inside the spinal column. There is a long foramen, an opening in these vertebrae that extend all the way to up to the brain. And the spinal cord runs through there. And on the sides of the vertebrae, we have these openings called the intervertebral foramen to allow the spinal nerves to go into the spinal cord and come out of the spinal cord. And we see it on our model. Put this up in the model. See what's missing on this particular view on the screen right now. There are no pads. There are no discs between the vertebrae. This is not how the vertebrae look in our bodies, because we have pads of cartilage in between each vertebrae, because we don't want the vertebrae to rub together. It's very painful if that happens. So we keep pads of cartilage there to protect them. So let me show you what this looks like here. This is a pad of, let me zoom this in a little bit. Okay. This is a vertebrae. This is a pad of cartilage right here. There's another one. There's another one. These yellow things are spinal cord, spinal nerves that are coming into and out of the spinal cord. The spinal nerves come into and out of through these foramens. This is what the foramens look like here in the sides. You know, on a smaller model, they look. Zoom in a little bit on this. Okay, there's an opening right there. And you can see this is a spinal nerve here. Its counterpart is over here on the other side. This big yellow thing in the middle is the spinal cord itself. And this is the body of the vertebrae here. This opening that you see is what we call the vertebral foramen that the spinal nerve travels from about lumbar 2, so somewhere in this region right about here, all the way up to the base of the brain.